Good morning, everyone. Actually, I'm Takeshi Kataoka, Senior Vice President of Renesas Technology. So, first of all, thank you for very much about inviting this forum. So I really appreciate always Taiwanese friends warm welcome. So thank you very much. So today I'd like to explain about automotive industry trend, actually from semiconductor supplier perspective. So let's go next. Okay. At first, I'd like to show our company's very brief introduction video. Please see.
Renesas was born after three Japanese technology giants, Hitachi, Mitsubishi Electric, and NEC, took the bold step of merging their semiconductor businesses to create one company. It is from this rich technological heritage derived from these companies that the foundation of Renesas is formed. Our proven technology and unwavering commitment to quality are what set us apart from our peers as a world-leading semiconductor company. More recently, Renesas began expanding its footprint in Silicon Valley, first with the acquisition of Intercell in 2017, and then IDT in 2019. Renesas successfully combined its proven quality with top-class safety standards and technical competency, with the innovative products and entrepreneurial spirit of Intercell and IDT. In 2021, Renesas completes its acquisition of Dialog, expanding its footprint in Europe. With Intercell, IDT, and Dialog now in the fold, Renesas enters a new era as a truly cosmopolitan company with a progressive mindset and a modern vision to lead the industry. What is Renesas's purpose in business? Our purpose is simple: to make our lives easier. We do this by harnessing the power of technology to complement human capabilities. And our lives don't just mean the people who use the final products that are powered by our technology. It means the lives of our suppliers, customers, our employees, and their families. To make human lives easier, our products provide advanced driver assistance systems, alternative fuel vehicles, robotics and human-machine interaction for smart factories, state-of-the-art medical devices, home appliances with intelligence, data centers handling big data and data explosion, fast and low latency 5G wireless communication networks. To make our customers' lives easier, we deliver a vast array of semiconductor products such as MCUs or SoCs, analog and power, to provide complete coverage for the broad signal chain in electronic systems. Renesas customers win by tapping our rich portfolio of analog power and embedded processing solutions. Our winning combinations help customers accelerate their designs and get to market faster with high performance and high quality products. The winning combinations address the needs of new and expanded customers and continue to power our customers' systems with compelling products and solutions designed with our proven technology. Renesas has weathered many storms and changes and is in a constant state of transformation to become a stronger organization. We will continue this journey to make a better world through our technology and make a positive impact on the way we live and work. Here at Renesas, everyone can make a difference. Together, we can make change happen.
Okay, so then next, please. Yes. So, as the video mentioned, actually, Renesas is originally Japanese three company, Hitachi, Mitsubishi, NEC. And then we are strong about digital product, MCU, SoC. But after acquiring many analog company, IDT, Intercell, Dialog, so we are expanding our product portfolio. Not only just digital but also analog and power. So now we are offering very wide variety of product for solution for automotive, industrial, infrastructure, and IoT for various applications. So today I'd like to focus on automotive. So next. So this is the agenda. So at first, I'd like to explain about the mega trend in automotive. And then I will explain three key things for this mega trend change. One is the evolution inside the vehicle. This means the E-architecture change. And the second is the electric vehicle, of course, EV. And third is ADAS. Then I will summarize. Okay. So this is a mega trend in the automotive industry. So, actually, Watanabe-san also mentioned, now automotive industry is in a very big change in 100 years, So value of car is clearly changed. So now, especially, this case means a connected, autonomous, shared electric. This is a key, key component, key thing, key items for this big change. Especially autonomous means ADAS, also electrified xEV. These, two area application is growing very rapidly together with e-architecture change. So, okay. So, for example, this is a, big change from gasoline car to xEV. So, this shift, caused a significant change in the, requirement for a component level. For example, number of components is significantly reduced from gasoline to xEV. Also, power system control-wise, clearly change from conventional engine control to a motor control. Then, energy source also change from gasoline to battery. This means that, battery management is a key thing for, very good, power management. Also, no more transmission, actually. And then vehicle structure also, will be simplified in xEV. That means that, many new applications now coming for xEV. Okay. So, this kind of, very big change wise, actually value of car is clearly changed from conventional mechanical thing to more software and services. So now OEM and Tier 1 is very much focusing on, to make their own software platform and also architecture because value of car is now changing to such software and services. Then especially OEM tries to, define both hardware and software architecture to be optimized for such, software, platform. So because they think this will be a value. So for example, as you know, Tesla is making their own SoC, right? To optimize their, solutions. So in such sense, actually OEM, try to directly connect it with, semiconductor supplier and also, for example, foundry and, so such kind of direct communication is now happening. Okay. So, from here, I'd like to explain three key things for this big change. So first is the evolution inside vehicle, means the e-architecture change. Okay. So, as you can see, left side, this is a conventional old, automotive architecture, distributed architecture, which means, each ECU connected, very complex manner. So, but, due to a system, will be a complex, also, number of ECU will increase, then now it's very difficult to make software and the system for this kind of, complex architecture. So that's the reason why now OEM and Tier 1 is shifting to a more centralized architecture, which has a, central gateway and also domain control. Central gateway is, operating, data, communication, and also domain. Each domain control is operating each domain. Domain means application. For example, powertrain domain and chassis domain, also body domain. So this, centralized architecture. Actually, this is called the domain architecture. Will enable, OTA software update, also scalable software development, also, wire harness, reduction. But, more advanced, architecture-wise, now, especially emerging OEM like Tesla and BYD, also other some OEMs try to move more simplified architecture, named zone architecture. So this zone architecture is composed by a central gateway plus each zone ECU. So zone means a location. So each zone ECU is operating, application for such locations. So this will enable, further OTA software upgrade, also further reduction of wire harness. Okay. So this kind of e-architecture evolution will simplify and optimize to achieve software-defined car, which OEM is now very much focusing. So, but to realize this zone type of architecture, actually zone ECU must be more flexible for software usability and software portability, because depends on the car model. OEM think they want to reuse their software asset across car model or across car generations. So they want to use same software between a zone or between a gateway and zone. So this is a very fundamental thing. Okay. So for such high software usability and portability, this is a key thing for zone architecture. But because this will lead the first time to market, also lower development cost for OEM and tier ones. So Renesas is offering full scalable solution with software IP commonality to realize this software reusability and portability. I will explain later about this. Okay. And also Renesas is offering total solution for various automotive application from high-end to low-end. As you can see, for high-end, high-performance computing for ADAS gateway infotainment, and then domain and zone control, also conventional control, vehicle control, by using our MCU, and also actuator and sensor thing to manipulate a motor and such kind of thing by using our 16-bit micro for actuator and sensors. So, okay. So now let me show our central gateway solution. So please.
In a world switched on, Automotive Ethernet will become a game changer for the next generation of vehicles and mobility. While CAN has dominated the car network for nearly decades, we face a revolution for the in-vehicle architecture when moving to Ethernet-based networks. Exponential growth in bandwidth combined with the quality of service allows innovative new architectures to improve comfort and safety in order to pave the way to a highly assisted and finally the fully autonomous car.
With our partner CTTech, we have developed this evaluation platform called Vehicle Computer 2. It represents a multi-gateway solution that supports all major automotive communication interfaces covering LIN, CAN, FlexRay, MOST and Automotive Ethernet, and allows flexible routing between all of them. The box is equipped with the powerful Renesas RKH3 SoC, the RH850 F1K microprocessor, and an FPGA-based implementation of an Ethernet TSN switch. With these components, the box provides the most common automotive interfaces in a robust housing. The box can be used by OEMs, Tier 1s for evaluation, prototyping or data logging, and expands the existing toolkits with automotive-specific requirements. Due to the variety of interfaces, many use cases are possible. Central gateway, zone ECU, or central computer are just a few examples.
In order to demonstrate this technology and to showcase the features of deterministic Ethernet, we developed a demo based on the VC2 in an in-vehicle network with a zone-based architecture. The demo consists of 5 gateway ECUs that are connected by Automotive Ethernet and CAN-FD in different network structures such as ring, star or mesh. A centerpiece of the demo is the ability to operate the IEEE 802.1cb standard for frame replication and elimination for redundant communication. These simple RC-type model cars have been equipped with front cameras that send the live stream from the driving track to the front zone ECUs using wireless technology. These ECUs forward the video to the central ECU for track detection, path planning, and driving control. The steering and driving commands are then sent by the rear zone ECUs to the RC control of the model cars. With disabled frame replication mode, any failure on a link will immediately stop the car in operation. Now, after enabling frame replication, the cars move on because the existing links between the boxes will use both directions. Mesh mode offers more redundant links between the boxes. Such configuration tolerates more link failures. Finally, a mixed network with CAN-FD and Ethernet also covers network diversification, which is an important element for functional safety. The backup for control traffic is covered by CAN-FD. So even with failures on both Ethernet links, the actuation control is still in operation. Thank you very much for your attention. I hope to see you soon on a live event from Renesas.
Thank you, Ube. Okay. So, okay. Yeah, next. So again, to realize such kind of zone architecture, Renesas offering full scalable lineup from low end to high end. As you can see, 16-bit micro, 32-bit micro, also high performance SoC for various applications. Then a customer can enjoy their, software asset reusability. As you can see, right side. This is somehow, approximately, reusable ratio, roughly 70 to 80% across car model and across applications and across generations. Okay. And also, one more very important thing to realize, software-defined car is a shift left based on the digital twin. This means the digital twin means, physical world and virtual world. So our customer really want to focus on, system level requirement, definition, also software development, apart from, real hardware, real silicon. So Renesas is offering, software, virtual software development environment, like, simulator and emulator model, right? So customer can enjoy by using, such kind of, development environment in cloud-based before real silicon come, okay? So this will be a very big benefit for both our customer and also Renesas. So for customer side, clearly, they can start their development, also, evaluation before real silicon come, means that they can, reduce, development time. This is good for time to market. So for Renesas, good thing is, we can get feedback from our customer about our product specification, definition, and architecture before real silicon come, which means that, by getting such, feedback, we can modify or change our architecture of product, even definition, specification. So this will, this will lead, our product very competitive. Also, to avoid any rework after real silicon come. So, these, big changes are happening in, semiconductor world with our customers. Okay. So next is XEV, sure. So yes, XEV, market is very much expanding. So there are several key applications as an inverter for motor control, onboard charger for battery charging, and DC-DC. This is for power management, also battery management system for battery management. So Renesas is offering, our product for all these, applications via power product via SiC and IGBT, also analog product via PMIC, power management IC, also BMIC, battery management IC, also, sensor and also gate driver for power, power semiconductor. Also with our, strong MCU for control these, XEV applications. So let me see our inverter solutions, please.
Renesas Electronics XEV Inverter Reference Solution. This reference design from Renesas Electronics offers the world's smallest 100 kilowatts class inverter to address the rapidly growing market for electric and hybrid electric vehicles. The hardware design is complemented by a calibration tool to maximize the performance of the motor and motor control software to optimize the performance of the host microcontroller. The hardware design includes the Renesas RH850C1MA2 microcontroller, optimized for motor control with a built-in resolver to digital converter, power management IC designed specifically for RH850, high voltage gate driver with built-in micro-isolator technology, and the IGBT and FRD power stage devices. Using this 100 kilowatts class motor bench, Renesas can accurately measure motor parameters and evaluate system performance using the incorporated hardware and software. Renesas is also readily available to help customers realize new requirements at the system level. Renesas has built up a demonstration vehicle equipped with this inverter and confirmed its performance in actual driving environments. Customers can utilize this solution to easily realize a highly efficient system and immediately evaluate a prototype inverter system in an actual vehicle. Prototype development that typically takes 2 to 3 years can realistically be cut in half.
Thank you. Yes. So Renesas is offering, total solution, digital product, MCU, SoC, analog, and power with software. Even with, software developed environment, as you can see. So actually, now XEV market is, changing to more downside. Downside means that, each application of XEV means that inverter and onboard charger and DC and battery management system will be consolidated to one ECU for reducing cost and also space, also wire harness, right? So Renesas can offer total solution by using our product, especially, our MCU is very powerful. So, our MCU can handle, all application by one MCU. So this is our solution. So customer, can enjoy, system level optimization by using our turnkey solution. Also, this will accelerate customers' development. Okay. And yes. And one more important thing about XEV is the power semiconductor itself. So as you know, now IGBT but shifting to SiC for inverter control. So maybe both will be used anyway due to some reason, cost reason and or supply reason. But actually, Renesas also, will offer, both, IGBT and SiC. So as you can see, left side, our IGBT wise, as you can see, total loss is, better actually, compared with our competitor. This is, very much, benefit for our customer OEM for longer distance driving with, longer battery consumption time. So this is a key, characteristic for, this, IGBT for XEV. And then we already, decided to expand our, internal capacity in Kofu. K6 is a Kofu in Japan to expand, our production for IGBT, 12-inch IGBT. And then right side, this is a SiC. So yeah, we also, decided to, invest for our internal fab for mass production for SiC. So our SiC, characteristic, actually switching loss is also, best in class performance for EV inverter. Also, we already did, completed automotive qualified. So Renesas will continue to offer both, IGBT and also SiCs. Okay. So last portion is ADAS. Okay. So about ADAS, actually, there are, several key applications. So sensing-wise, yes, of course, camera, LiDAR, radar, these three, sensing is very important. Then, from these, data from such sensing, computing, high performance computing is very important by using central ADAS SoC, also gateway for data handling, also domain and zone control. Then actuator side, 60-bit micro will handle real driving and braking and steering. So Renesas can offer total solution for these all applications by our SoC, MCU, also analog devices. Okay. So this time, let us see our autonomous driving solution demo, please.
So what we're going to do is take this car for a test drive on a track in the autonomous driving mode, so you can see some of these areas of autonomous driving that we're studying. So if I use the HMI here to enable the system and press the automated drive button, we start moving. And right now, the vehicle is able to follow a path onto the outer loop of our track, which is defined by a high definition map. Here you can see a vehicle that is coming. Our car has detected that vehicle. We wait for it to pass, and then we can proceed. So we're also able to use our cameras to detect traffic signs. For instance, this 20-mile-per-hour sign, we've detected that. You can see that on our display, and so the vehicle is going to hold that speed. You'll see that we're detecting many signs throughout the track, including this construction sign. And you'll notice that once we've detected that sign, a cue comes up on the HMI asking us if we would like to check for an over-the-air update of our high-definition map. A lot of times a construction sign could be, could signal to our system that maybe the environment has changed and we might want a new map. So if we go ahead and accept the update, what we've just done is triggered an over-the-air update, and this is done with a secure mechanism that we created in cooperation with our partner, Ubiquity, in order to bring that high-definition map into our system through a completely secure channel. Continue around the outer loop. What we'll notice is that the vehicle is able to maintain position perfectly in between these lane markings. These lane markings are actually very important to us. We can use these as visual cues in order to determine where the vehicle is on our high definition map. So thus far we've been staying on the outer loop. Now I'd like to go into the intersection portion of our track. And the way we tell the car to go in the intersection is by using the turn signal. Now, as we turn into the intersection, what we'll find is that with this intersection, we have 4 traffic lights. And each of those lights we detect with this car with a combination of both V2X and the cameras on our roof. The cameras can actually look at the light and tell if we're green, yellow, or red. We wait at the red light, and we want to go left, which we tell the vehicle by using the turn signal. But of course, we've also detected a vehicle that we have to wait to pass us. And once the vehicle's passed, we can make our left turn. Of course, the vehicle detected with both cameras, V2X, and LiDAR. We come to a stop sign that we've also detected with the cameras on our roof. And now, with a clear path, we can go ahead and turn back onto the outer loop. So now we're going to go ahead and turn back into our intersection, which we use with the turn signal. Only we're going to make things more interesting. We're actually going to fail, using our HMI, one of our vision processors, right? What you'll notice is that we still have full functionality. Our vehicle will still turn in the intersection, only now our car, having noticed that we have a failure, is looking for a place to park. But as you notice, all of our parking spots are full of cones, pedestrians, things that just make the parking spot not empty, and therefore, despite the fact that we detected it, we can't park there. So it takes very advanced computer vision to tell that you have a parking space, but you can't park there because there's some object in the space. We still have enough functionality in this field mode to wait for our red light to turn green. Now that our light has turned green, we will go ahead and proceed. And here we actually have an empty space. The vehicle detects that it's empty, and we go into a parallel park to pull over into our fail operational location. So this entire time, we've found that we've either been in our drive route mode. Now I'd like to enter the third autonomous driving mode we have in our system right now. We call that drive parking. And when I press this button now, our system immediately is looking for our home parking space. And so what it'll do is it'll continue driving the outer loop. And then when we get to the end here, we're actually going to make a left in the car automatically because it knows that our home parking area is right here. And as we pull in, immediately it's looking for an empty spot, that there's a parking space candidate based on the lane marks, and it goes ahead and pulls us into our home parking space. And that concludes the demonstration.
Thank you, John. So, okay. Okay, go back. Yes. So, this is, Renesas offering for, especially for high performance SoC. So, we are offering, very wide variety of, SoC from low end to high end for high-end application, autonomous driving, and also ADAS and gateway, cockpit IVI, and cluster by various, products. Okay. Then, so one more important thing of, ADAS evolution. So, now currently, basically ADAS function is level 2 or level 2 plus. But, in the future, such kind of, level will evolve to a level 3, maybe level 4, I'm not sure. But so for such evolution, number of camera and radar will significantly increase. Also, important thing is fusion operation. By using both, camera and radar, data, it will be a key thing to realize more precise image and object detection. Okay, so up to now, actually, Renesas is focusing more central ADAS and camera by using our best-in-class SoC for camera with very low power consumption. But by acquiring radar company, actually named Stelladian in India, actually we are now expanding our solution space to more adding radar actually. So our radar MMIC is best-in-class with advanced 20 nanometer RF CMOS, actually fabricated in Taiwan. So anyway, so then also this our SoC can handle both camera and radar data in a fusion manner by using state-of-the-art AI operations. So this will enable OEM to make more precise image and object detection for ADAS. Okay. So then summary. So again, automotive industry is in a very big change in 100 years. So Renesas is offering very wide variety product, as you can see, to support OEMs and Tier 1 to make their own platform, software platform architecture. But of course, Renesas cannot do everything by ourselves. So Renesas is, working, collaborating together with our partners, means, foundry, OSAT, raw material suppliers, EMS, and ODM, and IDH, right? So, yeah, and I think, automotive industry wise, long-term trust is very important because once mass production started in automotive, it will continue very long time, 10 years, 15 years, 20 years for automotive normally. So, under current geopolitical situation, also, supply disruption in these several years, yeah, OEM and Tier 1 is really realized. Also, Tier 2, Renesas really realized supply chain with trust, long-term trust relationship is very key thing. So I believe, I think Taiwan and Japan must be a best partner for this kind of, very long-term relationship. So let's work together, collaborate more for future success. So thank you very much. 谢谢.
Thank you, Mr. Kataoka.